In this video, we're going to look at how to find angles for the first time in triangles. So if we stick with our right angle triangles that we had in the early part of junior cert trig, we know that we have this side here, the diagonal, what we call the diagonal, we are now going to call the hypotenuse. And the letter H is going to be really important here. If we label an angle inside the triangle, we call this the angle B. There's two other sides in this triangle that B has a relationship with. There's this one here, opposite the angle B. And there's this one here, which is alongside angle B, or we're going to call adjacent. And this A in here for adjacent, this O in here for opposite, and this H for hypotenuse, which is always the longest side or the side opposite the right angle. We're going to create a word with them. Bear with me for a minute. SOCA TOA. And these are relationships with three words you're going to see in your calculator. If you look at them now, sine, cos, and tan. And the O and H, the A and H, the O and A are the sides in the triangle. Depending on where the angle B would be, the angle B could be up here up the top, but in this case it's not. The opposite angle will be down the bottom then. So O and A can change around, but H can't. So these relationships, these fractions, sine is equal to O over H, always hypotenuse. Cos is equal to A over H, always again dealing with hypotenuse, and tan deals with O over A, which is the two straight sides. Always the two straight sides. So if you see the two straight sides given to you in a question, you are using tan. So take these notes carefully into your copy, and then we look at how the question could be asked. So, question like this, find the angle B. I'm going to leave the relationships up here. What have I just said? We have the two straight sides. We're dealing with tan. Because if we label this triangle, H is the hypotenuse, the side opposite the right angle. A is the side beside the angle, and you'll always find this relationship between H and A. They always touch off the angle given. And then this leaves this one as O. So O and A are what we have here. We have O and A. If you want to write that down, it might help you at the beginning. We have O and A. And now you're going to write this at the top of every page when you're doing trig until you get good at them. Which one is O and A? Tan. Or you can just remember two straight sides as tan. But always label the triangle. You don't want to get O and A upside down. So we can say that the tan of the angle B, the sides that has a relationship with are the opposite over the adjacent, O over A, 1 over 1. So you can also see this magic button on your calculator, the inverse tan, and it's just going to be 1, but I'm going to leave it as 1 over 1 because if it's 2 over 3, you need to learn how to put a fraction into your calculator. So the inverse tan of 1 over 1 comes up as 45 degrees, which also tells us that if the sides are the same length going away from the right angle, the angles in here will be the same. So this is also angle B. It has to be the same. 45 and 45 is 90, leaving 90 and 90 to be 360. So let's look at one that deals with sine. So again, find the angle B. So we have a right angle triangle where we have the hypotenuse. I said that H and A touch off the angle. That's never going to change, which leaves O to be down here. So what do we have here? We have our 3 and our 2, which is O and H. So we use sine. Or use sin. I'll just write use sine. Or sine on your calculator. The sine rule has an E. So the sine of B, what's it equal to? What's the relationship with sine? Well, sine deals with the opposite over the hypotenuse. So opposite 2 over hypotenuse 3. And we use the function, the inverse sine minus 1 of 2 over 3. We type it into our calculators and we gives 0.81 degrees. That's 2 decimals. 41.8 will be 1 decimal, and 42 will be to the nearest whatever you're asked to round off to. So now let's look at one that has cos. So I've moved down a bit, so I've written SOHCAHTOA again, keep writing it. So in this triangle, what do we have? Well, we can see here we have H up here. We also have A down the bottom. H and A touch off the angle. Always label your triangle. O we don't have in this case. We could get it using Pythagoras, but we're not asked. We're just asked to find B. So find angle B. What have we got? We have, now, when you get really good at them, you're going to identify straight away from the triangle what two sides you have. You don't need to write what you have, but just until you get good at them, you're only starting them at this point. Please write this down to eliminate using the wrong ratio. So we have H and A, and the only one with H and A is cos. So the cos of B is equal to A over H, 1 over 5. And if we type into our calculator the inverse cos, you could write 0.2 if you wanted, or 1 over 5. And the inverse cos of 1 over 5 is 78.463 degrees, the degree symbol, or 78.46 degrees to 2 decimals, or 78.5 to 1 decimal, which would get it up to 79, even though it's below 0.5 here because of the 6, moving the 4 up to a 5. So 79 degrees to the nearest decimal if we kept rounding that way, but if this was rounded to the nearest decimal, it would be 78 degrees. So in a question like that, they wouldn't ask for the nearest degree. Probably be the nearest to 2 decimal places, 78.46.